session, and definitely, as we have a recording for this session, so we are going to publish it, shortly after the event. Thank you. So we have our next speaker, Saiyam, who is going to talk about Kubernetes at scale using Fleet. Over to you, Saiyam. Go ahead and share your screen.
Just sharing the screen. And let me just change the cameras and the screen. Share desktop. Hope you're able to see the screen. Awesome. So hello everyone, and welcome to Docker Meetup. Very excited for this one. It's been a long time. We haven't seen a lot of folks. We haven't talked. So here we are. And today I'll talk about Kubernetes at scale using Fleet. So a bit about myself. I'm working as Director of Technical Evangelism at CIVO, and these are some of my social media handles. So you can contact with me on Twitter at Saiyam Pathak. I run a YouTube channel where I post videos and do live stream, a lot of live streams with other community leaders, CEOs, CTOs, and other folks. So be sure to check that out. It's youtube.com/c/Saiyam911. I'm Docker community leader, CNCF ambassador, I'm CK, CKAD, and CKS certified as well. So, and yeah, you can join the Discord, Telegram. All these links will be posted in the chat. I'll ask Sangam or I'll post them myself after the talk. So let's start today's topic, which is Fleet. So basically, let's go with the history itself, and we'll try to keep it as as simple as possible, interactive as possible, and we'll try to keep up the energy as well. So Fleet has now Rancher does a lot of things, we all know, and Fleet is also another product by Rancher, which is now acquired by SUSE, but still it's under the Rancher repository on GitHub. So Fleet is open source project. The history behind Fleet. Now, K3s adoption has increased over time, and it has also, this color looks good. So K3s adoption has increased over time, and now people are running, a lot of clusters at edge. So when you talk about edge, when you talk about factories, industries, so people are running K3s at edge in huge amounts. So there are a lot of clusters. There are even thousands and thousands of clusters that they are running. Now, the challenge that they are facing is how to manage them. And at the same time, when the development of Fleet was going on, there was a term or the concept, you can say, GitOps was becoming very popular, and the vWorks company has done a tremendous job in GitOps, streamlining the concepts and everything else around it. So that's why Fleet at its core is basically GitOps. And GitOps at scale. Because why at scale? Because it is able to manage thousands and thousands of clusters. Now, GitOps is basically simple for the terminology, if you don't know. So there's a Git repo, you tree, and then you maintain the state and you deploy it across the clusters or in a single clusters. So what does Fleet do? Fleet also does the same. It deploys the cluster and renders the states. So it is GitOps at scale. But the first question that comes into mind is that there are existing solutions out there like Flux and Argo. Then why Fleet was required, and how it is made, and then its architecture. So let's see. We have two very important portions when we talk about GitOps, which is Flux and Argo. Now, when we talk about Flux is a pull-based model. That means it runs on a cluster. So you deploy, you basically will run Flux inside the cluster, and then it will be pulling from Git, and then it applies that particular configuration or the YAML or whatever it is, the application to the cluster. So that's a pull-based model. So it doesn't span multiple clusters. Then Argo. Argo is kind of a you can say a push-based model. It supports multi-cluster, and so what you will be having is you will be having an Argo server. So you'll be having Argo server, and then it will communicate with Git repo, and then it will push to the clusters. So that's how the push model of Argo works. Now on the very foundation level, we can think like Fleet works similar to Argo, but according to the folks at Rancher who built this, Argo architecture was not able to scale. So the scale at which Rancher was looking is thousands and thousands of clusters, and even up to million clusters, to be very honest, because they have a blog on that I will show you. So, but at least thousands of clusters they were looking at to manage, and Argo architecture was not able to scale at that level. And also it was not very good for disconnected clusters. So that's where they started with the Fleet architecture, the engine, and they started building Fleet the Kubernetes way. So it's basically the Kubernetes controllers that have been built, which I'll talk in a couple of seconds. And so they have built Fleet in Kubernetes way, and that's how. And they have the focus is for managing thousands and thousands of clusters. So let's see what Fleet offers. So Fleet is two-stage pull model. Now, in one cluster, so it is good for single cluster. Yes, you can run Fleet on single clusters, and also it is an open source project. It is a standalone project, and I'll talk about that particular aspect as well. So you have Fleet controller cluster. This is inside a Kubernetes cluster, and what it does is it will pull from Git. So we define the fleet.yaml file where we have defined all the configurations on how to pull the YAML files and all, where we have basically the templates of the YAML or the actual YAMLs or the Helm charts for the deployment to the cluster. So it will pull that information. Then it will see where to apply this or which clusters to update. So it has that fleet.yaml file from where it can pick the environment variables, and it will be able to see where it has to apply. And also it maintains a state which clusters has to update once the updation goes, because that's how the GitOps works. Now the next thing is Fleet agents. So Fleet agents run on the downstream clusters. So here Fleet agent will run, and it is also another controller. So basically you now see two controllers. So you are having two controllers. One is the Fleet controller, another one is Fleet agent. So both are separate controllers because they both have separate purpose. Now Fleet controller, the Fleet agent controller is special because it does two things. One, it sees the upstream Kubernetes cluster to see if anything has to be deployed. Second, it sees the local cluster where it is actually deployed to see the state of that particular cluster. So it does two things. And so Fleet agents run on the downstream cluster. It pulls from the centralized Fleet controller. So it pulls from the centralized Fleet controller, and also it sees the state of the local cluster where it is actually deployed. And so I hope this gives you a brief overview of what Fleet does and how exactly it is working. Now, keep one thing in mind: Fleet is built the Kubernetes way, and it is basically a group of custom resources and nothing out of the box that has been made. So all the Kubernetes resources are being used, all the Kubernetes concepts are being used to incorporate Fleet, to make Fleet. And the bundle definition is just the fleet.yaml file, which was called bundle.yaml previously when it was initially launched. Now it is called fleet.yaml. We'll also see all these in action as well. Now, Fleet controller can be installed as a Helm chart, and Fleet agent also can be installed as a Helm chart. So like I said, they both are two separate controllers. So fleet controller and fleet agent, they both are separate controllers and they both have to be applied separately. Fleet is a standalone project. Now, what do you mean by standalone project? You do not need Rancher specifically to run fleet on the clusters. You can run fleet on any Kubernetes cluster without even touching the Rancher portion. So the intent of that is donating it to CNCF and for the further adoption and all that. So that's why it is a standalone project. Now Rancher 2.5, since Rancher 2.5, fleet is already there. So it's part of Rancher 2.5 because of all the use cases that they have to incorporate. So there are two aspects to it. One, it makes life easy when it's already installed, it is shipped with Rancher 2.5. Second, even if the standalone project is not picking up the pace, then also there is a big use case for Rancher itself to use fleet, so it will be always part of Rancher. So anyways, fleet will be getting used by the community because either they use Rancher, they'll be using fleet, or they can use fleet as a standalone project. In both ways, it's pretty neat to use. I'll show you how, and it's powerful. Now, fleet supports three kinds of deployment. So you can actually define the whole cluster state inside the Git repo. So it's not only about the applications. So you can manage the entire cluster state. Like when you deploy a cluster, so you have set of tools, like you have security, you have network policies, you have maybe what else? Some basic apps, network policies, security policies. So all these, they might be there. They can be put inside the Git repo, and that Git repo can be used to be managed by fleet, and then fleet that manages all the clusters, C1, C2, C3, they will fleet will be able to create the cluster and manage the cluster state according to the Git repo. So everything can be defined in Git repo about about the cluster state that you actually desire, and fleet will take care of the rest. So you can deploy plain YAML files, you can deploy Helm charts, you can also deploy the Kustomize YAML, and in order to customize the overlays or customize the deployment to different clusters of a single app. So you can say that there is app 1. Let me just write it down. So there is app 1. Now what happens is you might want this app to have different values, or you might have different YAMLs for different clusters for a same app. You can have those as part of overlays. And inside fleet.yaml file, you can actually specify. So you can specify which clusters it has to deploy. And if it matches this label of the cluster, then overlay is used. And if it matches another one, then this overlay is used. So you can also define this inside the Git repository itself, where your application is there. You can have the overlays and fleet.yaml to see whatever you want to, wherever, whatever, with which configuration you want to deploy to the cluster. So that's how I would say it is easy, because it is not that complex. Documentation is fairly simple and the concepts are fairly simple. So that's how it is used at scale. I think this is enough for the PPT portion. Now what we'll do is we'll see fleet in action. So just give me a second. Okay. So we have this, and we go to, so first I'll show you maybe the dashboard. I hope it's not locked out. Yeah, it's not. So what it is I'll show you one thing. So for this particular demo, we have used Rancher, and Rancher 2.5 deployment has been done. If you want to see, I have it deployed, I think, on this server, kubectl getpods -n cattle system. Yeah, so Rancher is deployed here, and this is the file that I have used. So it's nothing, just a namespace creation, service account, cluster role binding and role, and a simple deployment of Rancher server, which is Rancher 2.5.0. And but I have changed the deployment to the latest one, so it should be 2.5.5, I believe, or 5.4. So that's where the Rancher is running. And I have also added additional cluster. So this is a CIVO K3s managed cluster with 3 nodes. And I have added this as an import cluster. So how to add it? You add cluster, import cluster, and then you just give it a name, test, and then you run this particular command on the cluster. So this will install all the cattle agents, and it will register it towards the Rancher. So like this, I have already done for the CLU2. CLU2 is another cluster, and the local one is the one that I just showed you, where the Rancher is actually deployed. So that was it about Rancher. Now, what we do is, since I told you Fleet comes pre-bundled with Rancher, where we can see it, let's go to the Explorer. So Explorer will show you. So Explorer does a lot of things. Like it will show you the monitoring, the complete view of the cluster and all that stuff. You can manage it from here. But what we are interested in is the continuous delivery. So when the very initial version of Fleet were launched, it was called Fleet, and then they changed this to continuous delivery because it actually makes sense. We are doing a CD over here, so that's how it looks like. Now there are 3 portions to it. First, let's see some of the examples and understand how you can make the examples, and then we'll deploy it to the cluster. So this is the documentation, fleet.rancher.io. I have already explained you the this particular diagram. Now what we do is installation, managing cluster, registration. So if you are running Fleet as just a second, Rancher Fleet GitHub. Just wanted to show you one thing, that it's a standalone project. We have seen one installation, which is via Rancher. Another installation is you install Helm, and then you have 2 Helm charts. You install them on a single cluster, and then if you have the multiple cluster, you use the registration. So you install the agent cluster. You first generate the cluster registration token like this. So you generate this, and then you will get the agent initiated. So install the agent with the Helm command. So this is how you do a standalone when you do not want to use Rancher. So you will still be having the Fleet controller or Fleet agent same, or you will be having Fleet controller and you will be registering multiple clusters to it so that you can manage fleet of clusters. So like this, it works. Then you have, these are some of the core concepts which I have already explained you, bundle, deployment, downstream clusters, token, and let's look at the examples. So Fleet examples are there, and you have a multi-cluster example, single cluster example. So this is a simple example where you just have plain YAML files of simple application where you have plain YAML files. It will look for Fleet will look for the YAML files, and it will deploy all the YAML files. And if you are running, so what we'll be doing is we'll be deploying it via the UI. So which is like creating it and filling all this information. If you are doing it standalone, since if you are not doing using Rancher, you will create a CRD. So you just create a git repo CRD and custom resource, and you deploy it, and it will basically deploy the application. So just a second. Let's look at multi-cluster, because this is very interesting. And let's go to the manifest. So I was telling you something about overlays. So overlays are the place where you define but basically the different patches, like you have spec replicas 3 for this overlay, and you can have different replicas. So you have no replications, and you have some specific roles. So you have set different overlay with different configurations. These are the configurations. And now if we go to the fleet.yaml file, now we can see the target customizations. So it is named dev and everything is match labels and all. For this particular cluster, you apply the overlay with no replication. Then for this particular cluster, you apply the overlay with this particular configuration. And then for the prod one, you apply these all overlays. So basically you can specify in single YAML about the configuration for different clusters, and you can label your clusters. You just label your clusters, and when the label matches with that particular cluster, then it will specify, it will apply the right set of YAML file or right set of Helm charts to specified clusters. So that's how powerful it is, and that's how simple it is. So that was a plain manifest, and you also have multi-cluster Helm example where you can give your values as well in the overlay section, basically the template section. So all these are there. Then you can have Helm customize, and you can also have Helm external repository. So that also you can give. So all these are already supported by Fleet. Now let's see how we can deploy this inside our cluster. I hope it works. So Fleet examples, we go to the dashboard. So this is a Git repo, and we create via the UI. So we give it a name, demo. We give the repository URL, and now they have few authentication modes that you can use with the branch and with the branch name. Let's see what is the branch name. It's main or master. Okay, it's master, so we are good over here. And we can add path. So let's not deploy everything. Let's just deploy simple. So let's just deploy simple one and deploy two. Here you can either select clusters directly, or you can do one more thing, which I'll just show you. So just you can select the target namespace and the service count. So let's just create and see if it works. So it has demo created. Give it a few seconds. And we can actually see what is happening here. kubectl git pods. So we are basically deploying on the other cluster. Yeah, we can see that it is getting created. So all the applications, they are just getting created, and you can see the resources. They are 3 out of 6 already deployed, and like this it will be. You will also see the state of them, which are ready and which are getting deployed. So this is awesome. So you can have clusters. All the clusters that will be registered will come over here. Now, interesting thing, you can create cluster groups, and you can deploy the application to cluster groups. Say I create a cluster group demo1, and I say put all the clusters in this group that has the label env prod. So it will automatically put all the clusters that are there with env prod, and demo has already that. So like this, you can have cluster groups. Now, if I go here and I create, I can actually deploy to cluster groups. So you can see a new option has come in the deploy to, and you can deploy to cluster groups. What it means is you can maybe have 500 clusters which you want similar kind of deployment. So you have them as a cluster group and deploy it to that particular cluster group. So like this, you can do the cluster grouping and deploy the applications. So it's pretty neat, and you can see the bundles that we have just deployed, and it's very new. So these are the bundles. So we call them bundles, what we have deployed, and some things are not ready because they are not available, or whatever is the reason, maybe the resources or something, but that's how it works. And yeah, it's pretty simple, and everything can be done via the YAML. So if you go here, you can see the YAML. I hope it loads. If it doesn't, we'll do edit as a form. Okay, interesting. I don't know why it is not appearing as YAML. Maybe might be a little buggy. YAML. Interesting. Anyways, so this works like this, and there was one thing, advanced thing that I wanted to show you. You can have annotations. Yeah, so basically in deploy to you can have advanced settings. Yeah, this I was forgetting this thing. So this is the exact fleet.yaml that I was telling about. So you go here and you have the fleet.yaml file, not in this one. Maybe the multi-master one has one. Yeah, by the way, if you do not supply any fleet.yaml file, the fleet is capable to automatically identify basis on some parameters like the YAML files or the customized files or the Helm chart. So it will try to find all those and deploy everything. And if you have the, obviously, if you have them, then probably it will see what are the values in the YAML, fleet.yaml. So you can see the cluster selector and everything over here, and that's what you have to apply over here. And you can see the cluster group. So basically the best part is you should always do the advanced so that this becomes your fleet.yaml file, and then you can deploy to different, you can basically do a single configuration for multiple clusters. So like this you can deploy, and it is still deploying. It has done 4 now out of 3. So probably, yeah, it will take some time. It is still in container creating, pulling the images and everything. So, but it's good. And yeah, that's pretty much it about fleet. And we are almost ready for this particular thing. It's just one warning. It's updating one. So pretty much simple, I would say, to use, though the mechanism beneath might sound complex, but what it is just doing is it is managing clusters at scale. And yes, it is highly available because it is just a controller. So if your cluster is highly available, your fleet itself will be highly available. So if your cluster is highly available, your fleet itself is highly available, and you are good to manage thousands and thousands of clusters using fleet. So that's pretty much it about GitOps at scale using Kubernetes at scale using fleet, or fleet is GitOps at scale, whatever you want to call it. Let me know if any questions. I'll stop the share.
Thank you, Saiyam. Thank you for the great presentation. So, looking at the question, are you able to see any question in the chat window? I don't see it yet.